Hi, I'm Thierry, the payload lead. The payload, which is in front of me, is designed to exit the rocket on its way down and land on its own. After it lands, which will probably be sideways, it has to right itself and level itself. Once this is done, it will take a 360-degree photo and send it to us. We can't touch the payload once the rocket is blasted off, so everything the payload does has to be pre-programmed. To complete this mission, we split the payload up into teams.
Hi, I'm Kevin and I'm the Payload Recovery Team Lead. The payload's recovery system is in charge of landing the payload safely after deployment. The payload has to fall from a pretty high height, so we land it safely using the parachute here. The parachute attaches to the payload right below the camera system. Once landed, the parachute can actually be detached from the payload so that we don't drag the payload along the ground.
Hey, I'm Jake. I am the payload sub-team lead for self-righting and stabilization. The self-righting sub-team is in charge of bringing the payload upright to an upright position from whatever orientation it lands in. In order to do so, as you can see, we designed 3 lever arms. Each one has a sensor in it to tell us how far each arm is moved. And before this, we created a prototype of the system before our final one. Moving on to stabilization. Stabilization is in charge of bringing the payload to level. As you can see, we also created a prototype of this system, which was really important in showing us what we needed to improve and fix to get to our final design, which you can see right here. We designed 3 legs which can fit into the payload just like this and lift the payload off the ground, since the ground may not be flat depending on where we land. Just like the self-righting system, these legs will also have sensors on them to tell us how far they moved.
Hi, I'm Peter. I'm the lead of the electronics and programming team on the payload. So the job of our team is to design, wire, and code our payload. Pretty much, in order to complete its tasks, the payload has to know things like how much it's moved and be able to actually move. And we do this using little motors to make it move and a lot of sensors so that it can know things about how much it's moved and things like its GPS location. We have a little prototype of all of our sensors wired up together, and we even have some of our little motors on this payload prototype, this more final one. We can take all of this information that the payload gets and transmit it to ourselves to read using wireless antennas, but the payload actually uses it in order to decide exactly what to do and when to do it. And it knows this from the code that we write on it. And to write this code, we actually write a function, put it onto the payload to run, and if it works, we're good and we move on. But if it doesn't, then something must be wrong, and we can go back and test and try something different. And that's known as debugging. So we can actually show our little payload move now.